Good morning, everyone, and welcome to today's lecture. In today's lecture, we are going to continue our discussion on combined or plane motion of a rigid body. In the previous class, what we had seen is that any motion, any plane motion of any rigid body can be taken as a pure rotation about a point, center of rotation, instantaneous center of rotation, or about an axis, instantaneous axis of rotation. And we had seen how we can find out that point in two different cases. When omega and VCM is known, we have seen how we can find out that point. We have seen the example, pure rolling as well. Pure rolling can be thought of as pure rotation about the point of contact. Then we had also seen how we can find out the instantaneous center of rotation if velocities of any 2 points are known which are intersecting, and we had done some really good problems based on this. Remember these problems because any one of these problems may appear in your examination hall. You can just continue on with this discussion and we can move on to the third case. And the third case is case number 3, when two parallel velocities are known. Two parallel velocities are known. So basically what I mean by this is you have this rigid body. It is in combined or plane motion. And you know any 2 points. Point A, the velocity of this point is VA. And you know velocity of point B, VB. Both are parallel, as you can see. One has to be more, one has to be less. If both are equal, then what will happen? Both V and VB are equal. Same in magnitude, same in direction. What type of motion the body will have? Huh? VA and VB both are equal. Vectorly. Then what will happen? What type of motion this body has?
Pure translation.
Right? It has to be pure translation. Well done. So this hand motion has to be pure translation then. Velocities of all the points are going to be equal in that case. That would be pure translation. But if they are not equal, like this, parallel but not equal, we can locate the center of mass. Center of mass. You can locate the instantaneous center of rotation. So again, I have drawn a line, and then I can geometrically also find out this point O. And this would be your instantaneous center of rotation. Do we understand this? Geometrically, it is very easy to understand. The body would be rotating like this with an angular velocity of omega. If I call this distance as RA, if I call this distance as distance of point A, RA, and if I call this distance as RB, you can easily say what you can easily say. VA magnitude wise divided by RA magnitude wise will be equal to VB divided by RB magnitude wise, and that would be equal to omega, or you can write VA as RA multiplied by omega, and you can write VB as RB multiplied by omega. It is very simple to see, yes or no, that you can find out the velocities in this way. You can find out the instantaneous center of rotation. Once you understand the instantaneous center of rotation, everything becomes very simple. Yes or no?
Yes, sir.
Anyone has noted this down? I'll give you 1 minute to note it down, and then I'll give you one question.
Completed, sir.
Now remember, these 2 points, whenever I talk about any 2 points, these 2 points, one of those points can be the center of mass as well. Doesn't matter. Must know the velocities of 2 points. Do we understand this?
Yes, sir.
So this is a question. And remember, and these questions you will only find in a JEE advanced paper. You will not find it in a JEE main paper. So this center, which is actually the center of mass, is moving with a velocity v. This in fact is moving with a velocity 2v. The mass of this rod is m and the length of this rod is L. There are two questions, two things that I want to ask here. The first thing is, where is the instantaneous center of rotation? And the second thing is, what is the kinetic energy of this rod? What is the kinetic energy of this rod? We understand this?
Yes, sir.
Again, remember, you have to do this question in the shortest possible way, the simplest possible way. I'll give you 2 minutes to solve this question, get the answer, and stay happy.
Sir, it is done, sir.
Yes. Got the answers?
Yes, sir. Instantaneous center of rotation is point A, sir.
Instantaneous center of rotation is point A. How did you get it? You can go like this. It will lie on this line. Then you can take this. So if I call, how did you get it?
Sir, yesterday we have done that rod problem, no, sir. Like it is, if the end of the rod is like V, then center of mass is with V by 2, and at the last end it is 0.
Good. You could have done this. Or if you did not know, so how to do this, you can just take similar triangles, and when you take similar triangle and if you draw it correctly, this point will be here. If you still don't understand, you can find out the ratios of this two, right? You will get the instantaneous center of rotation at this point O, and the rod will be rotating like this. Yes or no?
Yes, sir.
Understand this, everyone? Okay. What will be omega of this rod? It will be V by 2L. Yes or no?
Yes, sir.
V by 2L or 2V by L? I think 2V by L. Yes or no? I
Yes.
wrote it wrongly. 2V by L. So it is going to rotate about the center of mass also with the same angular velocity. Now, it is easy to find out the kinetic energy of this rod. You can find it out by pure rotation about the point A, right?
Yes, sir.
Half I about the point A is ml square by 3. Yes or no?
Yes, sir.
Into omega square. So that is. Do we understand this?
Sir, I is ml square by 3, sir.
No, sorry. ml square by 3. Half ml square by 3 omega square. You get the kinetic energy of this rod. Anyone understands this? Yes or no? I hope everyone got this answer. Shall we move ahead?
Yes, sir.
We again come to this question and keep on coming to this question because this is the most important thing that we are going to do. And this is the question. This is again a ring. It could be a disc, it could be a sphere, ring of mass m and radius r. The velocity of this point is v, and the velocity of this point, you can call this as the center, you can call this as the point B, is 2v. Again, the question remains the same. Where is the ICR and what is the kinetic energy of this? I'll give you 2 minutes to do this.
Done, sir.
Everyone, sir? Tell me the answer, sir. Where is the instantaneous center of rotation of
Sir,
this
it- on the surface, means point of contact.
point of contact? This is the point with zero velocity and omega becomes V by R. This is again the case of what? Huh? This is also the case of?
Pure rolling.
This case is known as pure rolling, which is coming. We are building up to this pure rolling, We are building up the entry of the hero. Hero will come, hero will come, hero will come. Phata poster, nikla hero. The hero will come out. What is the kinetic energy of this body?
It is 3 mv square by 4, sir.
So you can find out the kinetic energy by many ways. You can find it out by half I omega square plus half mv square, or you can just point it about the point of contact. About the point of contact, it is 3 mr square, no? 2 mr square. What? Mr square plus mr square, 2 mr square. Yes or no? It's not 3 mr square, it's 2 mr square. 2 mr square into omega square is V by R square. So it becomes mv square. Yes or no? Do we get this? This is not a this is a ring.
Yes, sir.
So that is the case where we have two parallel velocities and you can locate the center of rotation and do the problem accordingly. Now the last case remains, and what is the last case? Case number 4, two anti-parallel velocities. Two anti-parallel velocities are given. Two anti-parallel velocities are given. How is that possible? Hey, this is my rigid body. I have one point with a velocity VA like this, point A, and the other point with a velocity B like this. How do I locate the instantaneous center of rotation?
Sir, by joining the final positions of two vectors.
Final positions? Head of the two vectors. They are not final positions of the two vectors. Head of the vectors. Now you understand the geometry also. See, when you start seeing things, you will understand. So you understand the geometry. It's all about geometry, my dear friends. It's all about geometry. So this would be the instantaneous center of rotation. Do we understand this?
Yes.
See, it is very simple. No one understands rotation, but if you understand rotation, it is very simple. This is RB and this is RA. And you can simply write your omega as VA divided by RA magnitude wise, that will be equal to VB divided by, why I'm writing VB divided by RB magnitude wise. Anyone understand this? Yes or no? No, yes. Or this is going above our X. Saying bye bye. Now I have this. And again, I'll ask you the same question. What is this? What is that? You have a rod of mass m length L. And knowingly, I made one velocity as 2v and the other velocity as v. Mass of this rod is m and length of this rod is L. Where is, my dear friends, the instantaneous center of rotation? And what is the kinetic energy of this gentleman? Let's see who gives me the answer. No answers.
Sir, it is mv square by 2, sir.
Where is the ICR? First of all, tell me that.
Here is at L by 3 from point A, sir. On the rod, L by 3 from point A.
On the rod. Okay.
Length of
And line is not straight,
L
but
from point A.
okay. So you can understand by geometry, if I call this distance as x, v by x must be equal to 2v by something. So that distance, this distance has to be 2x. Yes or no?
Yes, sir.
Everyone understands this? If one distance is I call x, the other distance would be 2x. Now this x plus 2x will be equal to L. So your x becomes L by 3. Yes or no?
Yes, sir.
So this 2x becomes 2L by 3. So congratulations, I have located the instantaneous center of rotation and I know that the angular velocity will be omega. And how much is this omega, my dear friends?
3v by L, sir.
Omega will be v divided by L by 3. So it will be 3v by L. Now to find out the kinetic energy and know the instantaneous center rotation, just find out the kinetic energy from there. Half moment of inertia about this point L by 3. Remember, I have this center of mass as well. C. So it will be half. The moment of inertia about the center of mass is ml square by 12. Yes or no?
Yes, sir.
Plus m into how much is the distance of this from here?
L by 6, sir.
L by 6 plus m L by 6 whole square into omega square. Omega is 3v by L ka whole square. So solve this. You should get the kinetic energy of this rod. Everyone understand this? Yes or no? No, yes.
Yes.
Okay. So this is what we are supposed to understand, how to locate the instantaneous center of rotation. Everyone understands this? Yes or no? These are
Yes, sir.
more than enough problem. You will not find all these problem in any book. These are my creations. So this will remain my creation unless someone copies it from my videos. Anyways, let us move ahead and move on to our favorite hero. And who is that hero now? Who is going to come? Fata poster, Nikla hero. Who is that hero? Who will come out after following this poster? And in south part of the country, the big posters are still put, and I love them. So the poster hero is PR, and PR does not stand for any hero's name. It stands for pure rolling. PR, pure rolling. It's rolling. Let it roll, baby, let it roll. There was a very famous rock song when I was of your age. Let it roll, baby, let it roll. So let it roll. Pure rolling. What do you mean by pure rolling? And we have seen this pure rolling so many times that we understand. What do we understand by this pure rolling? So it is a special case of general motion of a body, and we just have to remember what all happens in this general case, and we have seen it so many times that we now remember it by heart. Yes or no? What will happen in pure rolling? Huh? This point of contact A remains at rest. There is no relative motion between the body and the point of contact on the surface. So this point A, basically this velocity of this point A, which is the point of contact, is 0. Do we understand this?
Yes, sir.
Pure rolling is a case of general rotation where there is no relative motion between the body and the point of contact with the surface. This is pure rolling, my dear friends. Do you understand this?
Yes, sir.
Now, this pure rolling in this case was happening with respect to ground, or we can say this pure rolling is a case of rolling with no slipping. And this no slipping will remind you of something that we have already discussed in the questions before. Yes or no? There should not be any slipping between the points. Do we remember no slipping?
Yes, sir.
Now, this can happen with respect to ground, or this can also happen with respect to any other body. It may not be ground. It may be any other body as well. It can happen with respect to this plank. There could be a plank which is moving with a velocity v, and there could be a circular thing, a ring or a disc on the top of it. And there could be no slipping between the plank and the body which is moving. Do we understand this?
Yes, sir.
Now, in this case, we had seen that if this body is moving with a velocity v, the velocity of the point A should also be equal to v. Yes or no?
Yes, sir.
If this body is moving with an acceleration a, the tangential acceleration a, this point A must also have the tangential acceleration a. Yes or no? So acceleration of point A must be also equal to the tangential acceleration a. Do we understand this?
Yes, sir.
Now, with respect to ground, if I talk and if I draw some diagrams, if this is rotating with an angular velocity omega and this is moving with a velocity v and the radius of this cylinder or this is r, we can find out a relation between v, omega and r. What will be the relation between v, omega and r? For pure rolling. You've done it 5,000 times in the previous two classes.
Omega equals to v by r, sir.
Velocity of point A is 0, and if you look at the velocity of point A, it will be v minus omega r should be equal to 0. That implies v will be equal to omega r. Do we understand this? Yes or no?
Yes, sir.
Anyone understands this? If I say that the angular acceleration is alpha and acceleration of this center of mass is a, you can also find the relation between alpha and a. What will be the relation between alpha and a?
Sir, A equals to R alpha.
The relation between alpha and a will also be the same. A will be equal to alpha r because the acceleration of this point A must be same as the acceleration of ground, and that would be equal. Do we understand this, or this has gone above our head saying bye bye? Bye bye sir, nikal gaya, bye bye sir. Huh? Gone above our head saying bye bye?
We understood, sir.
Pakka na sir?
Yes, sir.
We to understand sir, but then when the problem comes sir, then only we have a problem sir. We to understand everything sir. There is nothing that we don't understand sir. When the problem comes sir, then is the problem sir. That is when we don't understand sir. Isn't it sir? But now we will remember sir. Is that so sir? Yes or no sir? You will remember it, no sir?
Yes, sir.
Noted it down sir?
Yes, sir.
I'm looking for a diagram, sir. And I'm not getting that diagram, sir. That is the problem, sir. Okay, then I have no other choice but to use this diagram only. I'll use this diagram only. Okay. Now, I can use this one. You must have brains. And if you have brains, we can do a lot of things. Good. I'm praising myself. This one. Now, let us try to make some cases here and try to understand what is happening. Let us say that this lower thing moves with a velocity v1. Again, I'm talking about everything with respect to ground. Do we understand this?
Yes, sir.
This gentleman is, let us say, going to rotate like this with an angular velocity omega. The radius of this gentleman is r, and let us say that this gentleman is moving forward with a velocity v2. Everyone understands?
Yes, sir.
Now, this is pure rolling, or you can say rolling without slipping. So the case is rolling without slipping. This body is in pure rolling. Rolling without slipping. Can you tell me the relation between v1, v2, and omega? Which is rolling without slipping, my dear friends. Can you tell me the relation between v1, v2, and omega? And remember, take a deep breath. Open your eyes and you will see some beautiful things happening. You have 2 minutes. This is just to understand the concept of this. Once you are done, in the next class, rolling will be over and we'll be rolling over rotational motion. Yes, my dear friends. Shall I do it? Huh?
Sir, v1 minus v2 by r equals to omega, sir.
You don't have to actually say it in that way, but you have said it correctly. How you are supposed to do this? It's very simple. You take 1 point on this and you take 1 point here on this. Remember, there is no slipping. Now, the velocity of this red point is v1. Do we understand this?
Yes, sir.
The velocity of this red point is v1. The velocity of the black point should also be v1. Otherwise, slipping will occur. Yes or no?
Yes, sir.
Now, if you find out the velocity of this point, how will I find it out? That funda, velocity with respect to center of mass plus velocity of center of mass. Yes or no? Now it is rotating like this. So velocity with respect to center of mass becomes omega r. Yes or no?
Yes, sir.
And the velocity of center of mass becomes v2. Now, these two things have to be same. That implies, everyone understands this?
Yes, sir.
V1 should be equal to V2 plus omega r. This is the condition of no slipping between the upper wala body and the lower body. We understand this? Yes or no? No, yes.
Yes, sir.
Everyone understands this. This is the most important aspect of this entire gentleman. You understand this, everyone? Can I have raised hands from everyone?
Understood, sir.
Now we are going to do the same thing. With this. Are we ready?
Yes, sir.
This is the next question then. Again, this is a case of pure rolling without slipping. Can you find out the relation between A1, A2 and alpha? Huh? Is it possible for you to do this? You have 2 minutes to show me your talents, else I'll show mine. Yes, my dear friends. Anything that looks like an answer. This is not rocket science. So simple things correctly. We are done.
Sir, it is A1 plus A2 equals to alpha r, sir.
A1 plus A2 is equal to alpha. Chalo. Let us see how it is to be done. I'll take 1 point here. Remember about the directions and the signs and everything. What is the acceleration of this red point? It must be A1 in the forward direction. Yes or no?
Yes, sir.
What will be the acceleration of this point? It must also be A1 in the forward direction, tangentially. Now it is rotating like this. So that is going piche. So it has got an acceleration minus alpha r piche, because I'm causing this as a positive direction. So minus alpha r is piche, plus A2 is aage. Yes or no?
Yes, sir.
Now these two must be same. That implies A1 should be equal to A2 minus alpha r. That is the constraint relation. So your alpha, I will just write it like this. I will not write it in any other way. Do we understand this, or this has gone above and saying bye bye, bye bye, bye bye, bye bye, bye bye?
Yes, sir. We understood.
Pakka? Everyone? Okay. Now let us take the example of this one. Everyone has gone, everyone has done that? Yes or no?
Yes, sir.
Now take the example of this one. A cylinder is there and you have got a rope wound around the cylinder and one end of the rope is tied to the ceiling. We understand this?
Yes, sir.
I leave this cylinder. So what will happen? The cylinder will start to move down. Yes or no?
Yes, sir.
Assuming that it is rolling without slipping. I mean, there is no slipping. There is no slipping. Do you understand there is no slipping?
Yes, sir.
Can you tell me how, first of all, tell me how would be the direction of alpha? It will be accelerated. How will be the, what will be the direction of alpha and what will be the direction of acceleration of the center of mass? What will be the direction of alpha and why will the alpha be like that?
Sir, alpha will be clockwise, sir.
Why alpha will be clockwise? Why alpha will be clockwise? Why? There has to be reason. If you understand the reason, the problem is very simple then. Yes, why alpha is clockwise?
Sir, mg is acting downwards and tension is acting upwards, sir.
So mg is acting downwards, the tension is acting upwards. So
There,
first of all, about, I mean, it is free to, about which point it is actually going to rotate. The cylinder wound around a rope. Rope is there and I leave it. About which point it will rotate?
point of contact, sir.
Ah? Anything that is free to rotate will always rotate about,
Center of mass.
it rotates about the center of mass. It's going to rotate about the center of mass. There's no point on that. And the center of mass is going to move downwards. Now you can understand it as pure rotation about any point. It will be in pure rotation about some point, but that is a different case. That is instantaneous center of rotation. Any body that is free to rotate always rotates about the center of mass. Yes or no? This is going to rotate about the center of mass. Yes, and then you told me that the angular acceleration alpha is clockwise. Why the angular acceleration is clockwise? The only thing that can rotate it is weight cannot rotate it. Why is weight cannot rotate it?
It is acting on its center of mass.
It's acting on its center of mass, so weight cannot rotate it. So what is rotating it?
Tension in the string, sir.
And tension in the string would be like this. It can only rotate it in this sense. That is why alpha is clockwise. Do you understand this? The only thing that is going to rotate it about the center of mass is the tension. If there is no string, ding, it cannot rotate, it will just fall. Yes or no?
Yes, sir.
If you cut the string, how does it move? It cannot rotate, it just falls down. But if the string is there, it will rotate because string is going to rotate it. The tension in the string is going to rotate it. Okay, so alpha is like this. What about the acceleration of the center of mass? The acceleration of the center of mass will also accelerate. Yes or no?
Yes,
It will
sir.
have both motion, rotational as well as translation. Yes or no?
Yes,
What
sir.
will be the direction of this acceleration of the center of mass?
It is downward with G, sir.
Hey, don't move ahead in time. Stay in the present. I'm just asking you direction. Don't tell me the value. Value is not G. Trust me. Okay. So it's going to move downwards with an acceleration A. Yes or no? If I say that the radius of this thing is R, can you find out the relation between alpha and R? Do we understand this, or this has gone above our head saying bye bye, bye bye, bye bye, nikal liya sir, bye bye, nikal liya sir, bye bye. We understand how what I have done? We're doing something, huh? Do we understand this?
Yes, sir.
The question? Why it is rotating in which way? Why is it rotating in which way? So can you tell me the what? The relation between alpha and r. Remember, no one understands rotation. No one. Not me, not anyone in the universe. What will be the relation between alpha and r? Anyone with an answer? Eh?
Sir, alpha equals to A by R.
Alpha is equal to A by R. How did you get it? That is correct. The logic must also be correct. The logic is not correct, then you got it from Akkar, Vakkar, Bombay, Bo, Asti, Nabbe, Pure, so. Why A is equal to alpha? That is the correct answer.
Sir,
Sir, there is no slipping, obviously. Yes.
sir, at the point of contact,
At the point of contact, what do I do?
acceleration will act downwards.
Okay, so I take this point, the blue point. Wrong color. I hate wrong colors. The acceleration will act downwards. A will act downwards. Okay.
And alpha into R will be in the upward, sir.
Alpha into R will be upwards. Okay, then so far so good. Then I have to take one point on the string. What is the acceleration of this red point which is on the string?
0, sir.
Well done. The acceleration. This string is not going anywhere. It is not accelerating. It is fixed at this point. Yes or no?
Yes.
So the acceleration of this point is 0. So the acceleration of the blue point should also be 0 for no condition, for no slipping. And therefore A minus alpha r should be equal to 0. Or your A by r becomes alpha. Do we understand this? Yes or no?
Done, sir.
We understand this?
Yes, sir.
Okay. If this is the case, if I leave it, there is no friction, let us say. Let us not worry about friction. There is no friction, let us say. How does this system move? How does this system move? How does the system move?
Sir, mass will be moving downwards.
Let us say this mass moves downwards. Let us say this acceleration is a1. Okay. Then this is the center. This is the center of mass of this.
It is rotating clockwise direction.
It will rotate like this. Okay. Let us say this is alpha. Okay. What about the center of mass? Will it accelerate or not? Center of mass will accelerate or not? Simple question.
Yes, sir.
So in which direction is it going to accelerate?
Like it is in the positive direction of x.
Let me call this acceleration as a2. Correct? Yes or no?
Yes, sir.
Now, there is no slipping. Now, there are 2 points where slipping can occur. Yes or no? What are the 2 points where slipping can occur?
That is point of contact of string and
So, this is point 1 where slipping can occur. There is
yes,
no slipping here. Then,
and the pulley, sir.
okay. This pulley is frictionless. So, there is going to be this pulley is ideal. This pulley is ideal. So, slipping is going to happen here. This pulley is ideal. Forget about that pulley. Think about this thing.
Contact of surface and that body, sir.
There is no slipping between here and here. Can you tell me the relation between alpha, A2 and A1? Everyone understand this? What is going above our heads? Everything comes from logic. This goes here, so this goes here, then this will go like this. Nothing I'm making from my own head. Everything is coming from pure logic, pure physical reasons. I hope I'm making sense.
Yes.
Huh?
Sir, A1 equals to alpha R plus A2, sir.
That is the only relation.
And A2 equals to alpha R.
So there are two relations. Yes or no?
Yes, sir.
So what is the relation?
A1 equals to 2A2.
Yeah, that is correct. A1 is 2A2. So let us see, look at this point, the black point. This black point is at rest. Yes or no?
Yes, sir.
So this red point, the acceleration must also be equal to 0. It is moving in the forward with A2 and it is moving in the backward with
Alpha R.
alpha R. So the first relation that you will get is A2 is equal to alpha R. Yes or no?
Yes.
You understand this?
Yes,
See,
sir.
we are doing very tough problem. This is the toughest problem that can ever come in a JEE. Now, same thing should happen at the top. And on the top, what I have this red point. The red point is on the disk or whatever it is. It has two acceleration. It has one acceleration A2 like this, but it also has one acceleration alpha R like this. Yes or no? And both are equal because we have found it out, right?
Yes, sir.
Now there is a point on the string here.
Accelerating with A.
This, yes, well done. This is
One.
accelerating with A1. So A1 should be equal to
A2 plus alpha R. That is 2A2.
A2 plus alpha R, but that is equal to 2A2. Do we understand this or this has gone above our thing? Bye bye. Bye bye. Bye bye. Bye bye. Good. Well done. You understanding the dynamics, right? Then
Yes.
there is a small question for you, my dear friends. Bui, 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 bui. And bui, 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 bui. The diagram I have shown first. Diagram should be here. And the question is here. Two identical disks east of radius are connected by a cord as shown in the figure. The disk I rotates with a constant angulation alpha in the anti-clockwise sense. Can it rotate? Okay. On its own, it can only rotate in the anti-clockwise sense. On its someone rotating it, it can rotate in the clockwise sense as well. Find the acceleration of the center of disk 2 and its angular acceleration. The disk 1. Let's see whatever we have read. Is it any useful? And this is definitely a question of JEE advanced. Are we good enough? And obviously there is no slipping. Because if there is slipping, nothing happens. If there is slipping, we cannot say anything. Let's see who gets me the answer to this one. Can I hope? So if just I have to draw. This I rotates in the anti-clockwise sense. So this disk is rotating like this. Alpha. Alpha, alpha, alpha. Let's see. Just take a deep breath. Open your eyes, and the world is beautiful. Trust me. There is no slipping between anyone. And you have 2 minutes to show me your talents, else I show mine. Beautiful example. Beautiful. I was looking for some other question. I got this one. Yes, your time is over. And my time has started.
Alpha of angular acceleration of the second disk is alpha by 2.
Okay.
Acceleration is alpha into r by 2.
That is absolutely correct. Well done. Good. So now I take this black point on this and blue point on this. Acceleration of both the points should be same, yes or no?
Yes, sir.
What is the acceleration of the black point?
Alpha into r.
So what should be the acceleration of the blue point?
Alpha into r.
Alpha into r. The blue point here is the blue point of this point, yes or no?
Yes, sir.
Same string. So the acceleration should be equal to
R alpha.
r alpha. Now, let me assume that this is moving with an acceleration alpha 1 and it is having an acceleration a1 like this. Okay? I can assume this na safely? Yes or no?
Yes, sir.
Then I move to these 2 points. The red point is on this. Now what is the acceleration of the red point here? A1 downwards.
And alpha into r1 upwards.
Alpha into r1 upwards.
1 into r.
Sorry, alpha 1 into r. I also write the same thing. But I have a green point here as well. What is the acceleration of this green point which is under this? Zero, because it is not going anywhere. Yes or no?
Yes, sir.
So from here I get the first relation. And what is the first relation? The green relation. That
A1
these two must be
alpha,
equal.
A1 minus alpha 1 R equals to 0.
Very good. So from here I can get the green equation. A1 is equal to alpha 1 into R. Now let me move on this point. Again, there is a red point on the disk. The acceleration of this red point is A1, downward direction, and it also has alpha 1 R in the downward direction. Yes or no?
Yes, sir.
Now from this blue equation, I can get something. What I can get from this blue equation?
A1 plus alpha 1 R equals to alpha into R.
As easy as it gets. Yes or no? No
Yes,
or
sir.
yes. Now, once you understand this, in terms of alpha, you know everything. The only thing is, when this comes as a question, maybe this alpha will not be given, moment of inertia will be given, and you will be supposed to find out alpha and R. You can very easily do it. It will just take you to write the equations. So we will understand how to write the equations now. We have understood ding, 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 ding. And our hero has come, and we have seen what this hero does to all these things. Still pure rolling. We are just starting to roll. It will take some time for us to keep on rolling. So we will try to wind it up. Will not be done in the next class. So by the next to next class, we will be saying goodbye to rotation. And I'm sure that I'll be covering each and everything that is possible for me to cover and that can possibly come in an examination. I hope you understood this. The main concept of rolling is the point of slipping. There should not be the point of contact. There should not be any slipping. If you understand this, rest is very simple. It's just not that difficult. Chalo then, I'll see you in the next class. Take care. Please keep on practicing. The more you practice, and you will find, trust me, and I'll show it to you after your exam, which question has come from which part of the lecture. I'll show it to you. Take care. Have a nice day. Bye-bye.
Bye, sir.